There's so many questions that animals help us understand about ourselves. How does intelligence happen? How does it evolve? Why do some species solve problems one way and other species solve problems another way? If you want to understand something that we do as a species, that we're really curious, why do we do it? Animals often have answers for us. It might be because we share an ancestor. It might be that animals can help us answer why natural selection or evolution would have favored the thing that we're interested in explaining. Animals have something to say about all those questions.
Is a dolphin smarter than a chimpanzee? Is a dog smarter than a cat?
Brian Hare is an evolutionary anthropologist at Duke University, co-author of a new book called The Genius of Dogs: How Dogs Are Smarter Than You Think.
Good boy, Congo. Come on. This way. Well, probably the reason I study animal psychology is because of my pet dog growing up. His name was Oreo, and just like every dog owner, he'd look deeply into your eyes, and you'd look deeply into his eyes, and you'd want to know what he was thinking. This is my guy now. His name's Congo. What's going on through his mind, and how does he think about us, and how does he solve problems? That's what endlessly fascinates me. Good boy. Cognitive evolution is just like any other type of evolution. It means that there's changes in the brain that lead to changes in how animals behave, solve problems, interact with one another. And the study of cognitive evolution is trying to understand, well, why do those changes happen? What are the forces that drive those changes? So if we're talking about where we are in the history of understanding cognitive evolution to the exclusion of humans, I would say we're in an infancy. I think we know a lot about what is it that makes human psychology different from animal psychology. I think we've got a pretty good handle on that. Where we know nothing is how psychology evolves, how cognition evolves in the animal world. There's been so little attention and effort, and the reason is because every university has 0 to 1 people who studies animal psychology. So it's very hard if you're doing comparative cognition. You're comparing different species to one another, but you're the only person there. Who are you going to compare with? So we're going to link up everybody all over the world so that we can work together and compare animals. We're going to make a community. There are different forms of intelligence on this planet. For me, intelligence is solving problems that are going to help you survive and reproduce. Almost certainly they involve your brain that is representing, storing, and processing information you're taking in. If it involves those things, it's intelligence to me. There has been discovery after discovery where animals that people would not have thought could do anything particularly interesting have amazing types of intelligence and often challenge even our greatest abilities. Elephants have ultrasonic frequencies of communication that we can't hear. There's ultraviolet perception in many animals. We can't see it, but animals that are pollinating those flowers do. That's the first step, is the wide, diverse range of perceptual abilities that then problem solving and flexibility is built on top of. The best example, and I love to say this to people when they how can you say that an animal could be more intelligent than a human? And I always say, well, how'd you do on the echolocation test? Obviously, you'd be hopeless. We don't have the ability to echolocate. Echolocation has evolved multiple times in mammals. Bats can echolocate, and so can cetaceans. So why is it that that type of intelligence evolved in those species and it did not evolve in our lineage? Self-control, it's vital to almost everything that we do as humans or that animals do. Whether it's a social decision, what should I say next? What should I do next? To what should I eat? Where should I go? All of those decisions involve self-control. The first time we brought a lot of people together to work on a problem of cognitive evolution, we were able to present 36 different species with a problem that we thought would measure self-control. you have to resist making a response that seems like the obvious solution to a problem. What we found was that animals that have more complex diets, so basically they just eat different types of food, were the species that did better on these self-control tasks. Species that had a much narrower diet, like a panda eating bamboo, versus, say, a great ape. All apes, humans included, eat hundreds of different species. And so the idea there is perhaps when you're having to make decisions as you're foraging about what to eat when, and you have to sort of inhibit, oh, well, there's food here and I'm hungry, but actually I'm not gonna get as much out of the thing I'm sitting in front of. I should move to the next source where I'm gonna actually get a bigger payoff. And so you have to show some self-control. If you're just a panda and you're just always eating bamboo, I mean, there's always bamboo. You just eat the bamboo. There's really no need for self-control. So that gave us a hint that really the force that may be driving changes in self-control in evolution is diet, perhaps more than the complexity and, you know, the political machinations going on in animal social lives. Technically, chimpanzees and bonobos are more closely related to us than they are to gorillas. For all intents and purposes, they look identical. Chimpanzees are incredible at making tools and using tools to get food that they couldn't have access to. It ends up that bonobos aren't that good at it. Flip side is that bonobos are incredibly empathic. They're very sensitive to the emotions of others and get very upset when others are upset. Chimpanzees tend to be more aggressive, especially male chimpanzees. They will murder each other. Females can be coerced and beaten in horrible ways. Bonobos really don't do any of those things. So you have these two close relatives where, oh, which one's more intelligent? You know, is it a chimp or a bonobo? You might ask me. And what I would suggest is, well, that's the wrong question. The question is, what are these different species' cognitive profiles? And so I've spent, you know, a decade comparing chimpanzees and bonobos, trying to understand what is the psychology that produces the different behavior. And I think what we found in bonobos is that they are actually attracted to strangers. They actually have a preference for strangers, whereas chimpanzees are very fearful of strangers. And that really is the psychology that's leading to a lot of these behavioral differences in aggression. Friendliness was not something that I had on top of my mind as something that drove cognitive evolution. It certainly was the animals that taught me that. We presented chimpanzees and bonobos with a cooperative problem. Okay, 1, 2, 3, go! They had to pull a tray using ropes to be able to eat food. And while we've seen so much evidence for cooperation in wild chimpanzees, when we began studying cooperation in captive settings, trying to use experimental approaches, we had failed miserably to get chimpanzees to cooperate. Well, we finally realized the reason we couldn't get them to cooperate in captivity was because it really mattered who they were with. And if they were with somebody that they had a friendly relationship with, boom, they could cooperate instantly. But if there was somebody that they were intolerant of, they could never cooperate. And we could turn on and off their cooperative ability just by rearranging them with different individuals. Bonobos are far more tolerant than chimpanzees. We gave them the same set of problems, but they'd never seen it before. They didn't have any knowledge. And it didn't matter who we paired them with, they solved it spontaneously. They were friends and they were tolerant, so they could do it together. Yay, bonobo! So it really is, when you put them in direct opposition, knowledge versus tolerance in a cooperative task, tolerance wins every time. In many ways, bonobos are sort of like the domesticated dog of our ape family. Chimpanzees would be more wolf-like, and comparing everything from their morphology, their behavior, their psychology, their physiology, many of the differences we see between wolves and dogs, we see between bonobos and chimpanzees. And why is that? Why is it that you have these two distantly related pair of species that have become so similar in the way that they've changed from one another? What was the process that drove it? We think it's the same evolutionary force, and we think that force is selection for friendliness. If you were to ask me the species that is most like a human infant in its ability to communicate with us, it's not organisms like a chimpanzee or bonobo that have much larger brains and are obviously closer relatives to us. It's the humble dog that is so good at this.
Speak. Hush, 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 hush.
They share an evolutionary history with us for the last 25 to 40,000 years. Dogs evolved when interacting with hunter-gatherers, and then you look at the effect that selection for friendliness has. It doesn't take much to then imagine that as humans start living at higher density, that what do we do amazingly well is create garbage, and the garbage that we create is a new ecological niche. If you're a wolf that can sneak in and get close and take advantage of the resources that humans are producing as we start living at higher density, you no longer have to get kicked in the face and, chase whatever you eat. It's going to be a reliable, sustainable source of food. The selection, though, that's going to be acting on you is you're no longer afraid of humans, you're attracted to humans. And so what we think happened is over many generations, there was this really strong selection for attraction to humans and friendliness and a lack of aggression. All of those things put together, understanding our evolution, understanding the effect of domestication, and the fact that they have jobs. There are dogs that are helping detect endangered animals. There are dogs that are helping people with mental and physical disabilities. There are dogs that are checking for bed bugs, finding cancers. Makes dogs really one of the most interesting and important species to study. In many ways, dogs have converged and become more like people, more like humans than wolves. If you're a domesticated dog, you're really good at using human gestures. Understanding gestures is this amazing thing. It seems to develop extremely early in dogs. Of course, the reason we got interested in this is because it's the skill that is so important and early emergent in our own species as kids start to learn culture and pick up language skills. Using pointing gestures or using the direction that we look to infer what we want or where we want them to go, it lasts throughout their lives. It doesn't decline as other types of cognitive functions do. It's kind of remarkable. It's often misreported as some dogs have been trained to have a large vocabulary. That's not the finding.
Chase, frisbee, take frisbee.
The finding is that they, with one trial learning, are able to label an object, a novel object, and remember that label for a week or a month later. But that's not the surprise. If you were to show one of those dogs a picture and say, get this object in the picture, they could go get it. Now that may sound like no big deal, but that is effectively symbolic representation. One of the hallmarks of human language acquisition. And when they told me they were doing that, I thought, there is no way a dog is gonna do that. I can't even believe you're trying, but yeah, go for it. And not only did they do it, they did it really well. Lessons from dogs. Be nice. Don't bite. I think the thing that everybody loves about dogs is they're just always so optimistic that, now's gonna be the fun time. And then just so forgiving and loving. I hope I can be the person my dog thinks I am. I think we'd all be better if we could manage it. Good boy. I think the thing I'm most excited about with this diverse intelligence grant is I think we're going to discover new types of intelligence. I think there's species that have been ignored or have never been studied in how they interact with the world psychologically. We're going to find intelligence, flexibility, sophistication where we least expect it. And the hope is that, this effort will get us crawling and maybe even running if we're lucky.